it's really just one step along the way of how the sun is influencing basically the entire solar system. Inside the sun, you've got nuclear fusion powering it, and then you've got these different layers in the sun. Eventually you get to the surface, but then right above the surface you have the corona, and it's much lower density than the surface, which is why it's so much fainter. And then that material actually is unbounded. So unlike the surface of the sun where it kind of just stays there, the corona actually expands out into space and fills the entire solar system. And so if you really want to understand how to predict what the sun is going to be doing to the rest of the solar system, you really need to understand the corona.
Just to check something, did you misspeak? The corona extends throughout the whole solar system?
No, that is correct. Yeah.
No.
So I've had debates with scientists at conferences. It's sort of a classic, like over coffee, you make the joke that you could argue we are inside the sun right now. because the solar wind expands out and fills this big bubble we call the heliosphere, and it's it's well beyond the orbit of Neptune. And so the Earth is really far inside of this heliosphere. And the only reason we're not like directly being influenced by the sun in this way is because we have our wondrous atmosphere as well as the Earth's magnetic field, which sort of offer this little shell. So you can kind of think of it like if the heliosphere is like a big desert and it's dangerous to be out there, but we're in this little oasis that is the Earth that protects us from those nasty dynamics that, if you go out into deep space, you're going to be pelted with radiation all the time. And that's actually one of the big problems with going to Mars is how do you keep the humans healthy being in deep space that long because of all the radiation that you'd be experiencing.
That's one of those things where, like, I just can't even imagine that. Like, the sun is really that big? It's really that powerful?
Another way to define, the way we think of the sun in everyday life is, well, we look in the sky and there it is. And that's because of something in physics we call optical depth. And you notice this actually when you go out on a cloudy day, you see optical depth. So if you look up at a cloud, sometimes it's transparent, sometimes it's totally opaque. And when it's totally opaque, you kind of think of it as like a solid object. But of course, it's not solid. It's up there floating. It's just a bunch of gas. But if you get enough of it together, you can't see all the way through it. And so that is sort of one way to define where the surface of the sun is, or that's really how we define the surface, is that it's where can we stop seeing any further. So you hit like a barrier optically. So that's one way to define the sun, is how we see it this way. But I'm taking the argument that yes, but then the solar wind fills the whole solar system. So by a certain perspective, it's really all the sun. And we're just in these little dust particles that are the terrestrial planets. We're orbiting around this, or inside of this thing, and we've got little magnetic field and a little atmosphere that protects us. But really, that's sort of an exception to the rule that is the dominance the sun has in the solar system.